we will finish up these questions on the study guide, okay? Excuse me, my ankle was itching. Okay. What neurotransmitter, now we're on number 14. What neurotransmitter is associated with our mood? Well, the neurotransmitter is called serotonin. And I got to get back to this blooming synapse again, okay? I got to go back to the synapse. We're going to talk about how antidepressants work. Right? So, in our limbic system, in our brain, it's kind of diffusely organized, which means it's not in one spot right there. We have a region of our brain that controls our emotions, all righty? Now, the neurotransmitter serotonin, S-E-R-O-T-O-N-I-N, serotonin. The S up here stands for serotonin. S-E-R-O-T-O-N-I-N, serotonin. Now, an antidepressant, let me back up. People that are depressed, supposedly, do not have enough serotonin manufactured, released, enough serotonin attaching to the receptor sites to regulate the receptor site, okay, to regulate the other neurons involved in our mood. So what you have to do is, how would an antidepressant work? So they take antidepressants, a Zoloft or something like that, a happy neurotransmitter, I think, the way I think I remember that. Anyway, I don't mention, I guess Zoloft is one. It's been a while since I even thought about the darn things. But anyway, so you don't have enough serotonin being manufactured. You don't have enough serotonin being released. You don't have enough serotonin attaching to the receptor sites. So bottom line is you do not have enough serotonin. So how might an antidepressant work? Well, it might be able to make more serotonin. It probably doesn't work that way, okay? It probably doesn't work that way, but I'll give you a couple of suggestions, possible suggestions right here. In other words, we don't have enough serotonin, the happy mood neurotransmitter, okay? So an antidepressant might work by manufacturing more serotonin. I'll put that up here. Serotonin might work, antidepressant. Might produce more serotonin. Probably doesn't work because there's something wrong with the manufacturing process anyway. So that's one reason that I'll put it up here, but it probably doesn't make much sense, okay? Now, probably they work by slow down the uptake. Okay, now, let me back up to this right here, Serotonin is released, serotonin diffuses across the gap, serotonin attaches to the receptor, serotonin regulates the target. All right, that's the way any neurotransmitter works right here. But what if right here, the serotonin that is released from its receptor site right here, what if we could slow down the reuptake of, excuse me, that blank. What if we could slow down the reuptake of serotonin? In other words, make what we have last longer. So that's what my next point up here is, make what we have last longer. Antidepressant might produce more serotonin, might make serotonin last longer. Longer, L-O-N-G-E-R. I don't know why it's happening like spelling, but anyway. So this is the way an SSRI works. Include the definition of an SSRI. Now an SSRI is selective serotonin reuptake inhibitors. Selective serotonin reuptake inhibitors. And I want that in your answer. SSRI. Selective serotonin reuptake inhibitors. SSRI. So the serotonin is released. It's not enough, not normally enough right here, but if you can slow down the reuptake of it, what you have lasts longer. And this is the chemical basis for an antidepressant, okay, because we simply don't have enough serotonin or the happy neurotransmitter. Anyway, okay. Define potential difference. Now we did that earlier. We did that on the first lecture, potential difference. A definition of potential difference. You can go back and take a look at question 3. Go ahead and redefine it for me. Potential difference is the difference in charges inside the cell versus outside the cell. Again, potential difference is the difference in charges, pluses and minuses, inside the cell versus outside the cell. Draw a cell. If you can draw this, fine. If not, you can explain it to me. Draw a cell that has a positive potential difference. If you can draw this right here, then go ahead and draw it. If not, you can go ahead and define it for me. Give me a few seconds right here to get rid of this right here. All right. Here's a cell. Here's a plus. Here's a plus. I got more positives on the outside than on the inside. Now, what I want to have, now this may not be the answer yet. Give me a few seconds right here. Draw a cell that has a positive potential difference. That means I have more positive inside than outside. Well, instead of me erasing anything, if I got 2 positives outside, I got to have 3 positives inside, okay? This is a cell that has a positive potential difference. I have more positives inside than outside. You can draw that, or you can just simply tell me there are more positive charges inside the cell or outside the cell. Some of you may know the word cation. That's fine. Use it if you want. If you don't, just tell me there's more positive charges inside the cell than outside the cell. These would be sodium or potassium. I don't need that in your answer, but these are the common ions that we have that define a potential difference. Okay? Now, besides medication, how might depression work? You're going to have to look this up. Treatments for depression, okay, besides medication. Bright light is I remember seeing that right there, okay? People that, especially in the wintertime, especially in Russia, they have a lot of hours of darkness versus limited hours of light in the northern hemisphere right there. And what they need is bright light, and they've done experiments with bright light relieving depression. So you can put down bright light for one. I would like at least 2 more. List 2 ways, 3 ways that depression might be treated besides medication, besides the antidepressants, okay? Look that up and see what you can get up. Name a neurotransmitter associated with Parkinson's disease. Well, that is dopamine. So the answer to question 17 is dopamine, D-O-P-A-M-I-N-E. Give me a few seconds. D-O-P-A-M-I-N-E. Dopamine, all right? Now, how does it function? Dopamine dampens motor output. Dopamine dampens motor output. Okay, it doesn't really matter where that it is. It's called the substantia nigra, but that's okay. Dopamine dampens motor output. Now let me explain dampening motor output right here. Motor output is a signal originated in the frontal lobe right there. Motor output gives us our normal motor movement. Walking is a normal motor movement right here. Now, if I'm not going to dampen that motor output, I'm going to have a very jerky motor output. Well, dopamine dampens that motor output for me right there and gives me this smooth coordinated movement right there. So without dopamine, I've got Parkinson's disease. I have very jerky motions. I have a friend who walks just like that. Just walks like that. Walks on his toes, and he walks just like that. He'll drive down to the house, and I'll go outside and see him and say, "How you doing today?" He says, "Can't get out of the car." He'll stay for a few minutes, and he'll leave, okay? But anyway, dopamine dampens motor output. Ankle itches like crazy for some reason, okay? That's what I want you to know about Parkinson's disease. What's the rate for depression? Now, I just look it up. I look it up every year right here. It's about 3% of the population that has some form of depression. About 3%. About 3% that has some form of depression, okay? I've never been depressed that I know of. Never thought about suicide that I know of, okay? I'm too much of a chicken to do it anyway. I can promise you that. Okay, this probably will be due by, let's make it due by in the next week, okay? Now I may go ahead and upload our last one. We've got one more after Easter, whatever Easter is, and that won't be much of an Easter. It won't be a typical Easter service. So, but anyway, after Easter we got one more on the musculoskeletal system, and I'll do that one for you. I may do it next week, and that'll be the end of the semester, okay? So do this one whenever that you want to. If you want to send it in tomorrow, it'd be all right. And I don't have anything for you to write on this one. On the last one I did, one-page paper on current versus new treatments for cancer. That was a one-page paper on that. Most of you did fine on that, okay? So I'll sign off right now. I'll get this thing uploaded here shortly, and we'll go from there. Take care. Bye-bye.